Hello and welcome everyone. Welcome to the Ethereum Engineering Group meetup. I'm Peter Robinson and today we've got Dan and Erik who are going to talk about MetaMask. So do the two of you want to introduce yourselves and before we start off?
Sure. I'll take it away. My name is Dan Finlay. I'm one of the co-founders of MetaMask. I've started in, I guess, the beginning of 2016. And yeah, right away, kind of got it good enough to build some applications on, started taking it to hackathons, getting developer feedback, and bit by bit, building up a tool that is increasingly used by normal users in addition to developers. And just last week, we actually finally launched our mobile app. So MetaMask is now useful in more context than ever. And yeah, so I'm happy to be here and yeah, answer any questions. And I'm joined here today by Erik Marks, a member of the team who really he has cut his professional teeth on MetaMask. He, straight out of college, we got him because he was one of the MetaMask interns, and like a little over 2 years ago is when he started, and he's been helping drive forward some of our most ambitious initiatives since then, including our permission system, which is a fundamental piece of our plugin system that we're working on in the coming quarters.
Yeah, I was started grad school in 2017 and was observing crypto from the outside during those very heady days, and then joined MetaMask as an intern in 2018, and I'm now in my second year as a full-time engineer on the team.
Well, cool. Well, thank you very much. So why don't you go ahead, share your slides and tell us all about MetaMask.
All right, I'm going to do the obligatory "can you see my screen" song and dance. Let's see, are my slides visible?
Yes.
Yeah.
Wonderful. Okay. So I understand that we have a somewhat diverse crowd here, and some people who will be very familiar with what I'm about to talk about. But we will go through the deck and our sort of general pitch of MetaMask and Web 3.0. And then once we're done with that, we want to take it into sort of an AMA, and there are a number of different topics we can go into on a more technical level as the audience desires. And so at MetaMask, we see our mission as democratizing access to the decentralized web. And when we talk about this, we usually start our pitch with discussing why the current model is broken. And then, so in the present web, in the sort of walled garden of Web 2.0 with your Facebook, Google, and Amazon, we see that people and their data have become the product. Anonymity leaks and privacy leaks are sort of endemic to that business model. And in order to drive engagement with users, we see companies engaging in all sorts of social engineering and creating addictive dependence on their applications and manipulating public discourse. And we've reached a point where many people, including ourselves, despise, like as users of these platforms, despise the system that's been created, to the point where we want to try to create something different. And to just briefly review some of the ways in which the Web 2.0 system creates problems for their users, we have practices such as privacy zuckering, aka forced oversharing, where you have this sort of veneer of user consent, where when you sign up for a platform or a service, but at the end of the day, you actually have very little control over the data that you ultimately share. And it's kind of like either you give the service the right to do whatever it wants to you and your device and your data, or you can't use it at all. We also see stuff like confirm shaming. So it's like, even if you try to opt out of the more sort of predatory business and privacy practices in Web 2.0, you'll be shamed for doing it. Of course, we also have Roach Motels, which is, first, you have, like, if you take Facebook or an Amazon or something, part of the value of the service in the first place is that they get all this data that they use to cater the service to you. There is no way for you to extract that data from the service and make it useful in other contexts. And then on top of that, they will also literally create artificial barriers for you to extract yourself from the platform. And we see ourselves, at MetaMask, we see ourselves as contributing a solution to this problem by being a gateway to the decentralized web. So we see ourselves as a way for people to interface with these novel decentralized services that we hope will create new, less predatory business practices predicated on user consent and user control over their own data. And when we talk about, and so we call this Web 3.0 or the decentralized web. And when we talk about Web 3.0, it's some of the values that we focus on at MetaMask, first and foremost, are privacy, self-sovereign identity, decentralization, user consent, and of course, security. And some of the features that MetaMask provides in order to access Web3 is user-owned accounts. So we can go into exactly what that means in the context of Ethereum, but the basic idea is that you as a user have complete control over your identity. And if you want to leave, if you want to leave MetaMask and take your business elsewhere, you're completely free to do that, and we do not host or control or own or keep any of your data from you. And sort of as a layer and as a service that allows users to interface with Ethereum applications, we want to ensure that that whatever these applications are asking users for is made explicit to the user, so that they are able to consent in an informed way to whatever interaction that the application is engaging in. So, for instance, if you're, and this is a long-standing, and there's a lot to say about that, but a very common example would be like when an application is trying to sign some data or create a blockchain transaction. We've spent a lot of time thinking about, how can we maximize and make accessible as much information as possible about this request to the user. And for that reason, we've been involved in developing standards such as, well, not quite a standard, but practices such as typed signing methods, so that users can see actually, like, this application is asking me to sign something, what exactly is it asking me to sign? We also try to ensure that users can share permissions and data progressively with an application, so that we don't get this immediate sort of all or nothing wall of text, let the application do whatever it wants, or you can't use it at all. And this is where, and earlier this year, we launched a permission system into production. That's sort of our first step in allowing the user to gain increasingly granular control over the privileges of applications that they interact with via MetaMask. Moreover, we want those permissions to be revocable at any time, and also at a granular level. And the way, and you can see in the little GIF we have going there that in this wireframe, where you can see for Uniswap in this example, the permissions that it has, and which permissions that are revocable and permissions that it requires in order to function at all, and then a very accessible way of getting rid of it if you feel like you no longer want that app to have any privileges. And so as this interface layer, we want to not just stay locked into the existing use cases on Ethereum, but we also want to ensure that we can support the extremely fast-paced innovation going on, not just in Ethereum, but in the decentralized web as a whole. So it's constantly a struggle for us to keep up with all of the different things that people in the ecosystem are working on. For instance, we have all of the stuff happening in DeFi. We have different layer 2 scaling solutions coming online, different layer 1 chains coming online, and while we've managed to be part of a lot of the growth that's happened on Ethereum since its inception, we also want to make sure that our users are able to use us to branch out and talk and communicate with the rest of the decentralized web as it's coming online. And in support of that, our next sort of big strategic focus is our MetaMask Snaps, our plugin system. And here the idea is it builds off of the permission system that we introduced earlier in the year in order to sort of extend the functionality of MetaMask at runtime. So for instance, we have built a very tailor-made technical stack to support interacting with Ethereum applications. But when you have, but the more layer 1 protocols we have coming online, and a lot of layer 2 protocols as well, it's impossible for us to build bespoke implementations for each of them. And our plugin system is our attempt to open up MetaMask and remove ourselves as a bottleneck and allow users to extend the functionality of our platform at runtime in order to say it could be used to support Bitcoin, it could be used to support ZK rollups, and any number of different protocols. And so we understand that and for this talk, we can share these slides afterwards. We have some, because we were told that there might be some dApp developers of different levels of experience listening in. We have some resources that we recommend for getting started building Ethereum applications, and we'd be happy to share those. But other than that, that is sort of an introduction to MetaMask, and we'd very much like to open it up to questions from the audience and sort of focus in on topics that are the most interesting to you. Thanks.
So if you're not going to present, well, maybe unshare your slides so we can all see each other. Maybe, yeah, cool. So does anyone have a question, or I can lead off a question to kick off the conversation?
Oh yeah, just briefly, sorry, I guess I should have read earlier, but when we were, I guess, criticizing the data model of existing companies, it's not quite clear to me, how does MetaMask how do you guys get your funding?
Yeah. Okay. Yeah, we'll go straight to the business models end of the spectrum. So far, MetaMask has been very fortunate. We have run for about 4 years, basically on the goodwill of Consensus. We are exploring some revenue models within the wallet in the near future. We have some ideas for how we can basically provide additional services on top of the wallet experience that are totally optional. They're supplemental to the experience. But still provide enough value to the end user. So we haven't really premiered them. Like the only revenue model that's currently in place is there is like a buy ether within the extension and the mobile, and those have some traction. You know, we get a percentage on that. So I think the big theory is that if we make a trustworthy enough wallet, people, you know, we will find ways of enhancing the experience in ways that require some amount of like external trusted or some kind of extra service that we offer by default, and that can be an opportunity for that. But you know, with a foundation of it's always free to get in, you never really have to pay to do any of it. You can always opt for a decentralized connection. So we default to Infura, our own servers, but you can always configure it to your own full node. And yeah, so we tend to think that as long as we give users optionality, then we can just be kind of like the first one in line. Like here's the easy path. If you want that, we can do these things for money, but otherwise, you know, we're just trying to make an open ecosystem.
Oh, sounds good.
Another question?
Yeah, go ahead.
Hey, everybody. I have a little bit of a newbie question, so pardon me if it's too newbie. But how does a developer from their front end get information from MetaMask? Like, for instance, if a user has toggled to a test network like Ropsten, can we tap into the MetaMask object to get that information? Can we get information like whether or not a user is signed into MetaMask? I just find that I personally, as a blockchain developer, need a little bit, you know, I need to really master the API of MetaMask to get some programmatic control of how it works. Can you fill me in on that?
Yes. So the and I wrote our most recent implementation of the API that we expose to websites. So I'm very happy to talk about this. And basically what we, the way it works is, and there are, for historical reasons, when a user has MetaMask installed, we inject a JavaScript object into the DOM, and that object has our API. And it's a JSON RPC API, so basically it supports arbitrary message passing, and it maps to, and it allows you to do anything like request the ID of the currently connected chain, get the user's accounts, send transactions, whatever you may want to do. And Dan very helpfully pulled up our documentation of this. So there's both sort of the API that we inject, which is accessible as window.ethereum. And then there are, and that is enough to do any interaction with MetaMask or with Ethereum that you may want to do. It's like a very general interface. And then there are a number of convenience libraries that people use with it, like ethers and web3.js are the most common that provide APIs that some people find more convenient. Does that answer your question, Mark?
Yes, thank you so much.
Yeah, I'm looking for a link to the convenience libraries. And just to add a little bit there, so you saw that there's this general provider request, and it uses a JSON RPC. And then if you look to EIP 1474, this is what defines all of the methods that are supported. So here are all the error codes, and you'll see that there are many ones. There's ETH get balance. Get storage at is how you get the storage of a contract, or actually at a given address in memory space. There's a kind of low-level method, transaction count. Basically, so these are some of them, but there are actually many methods that at the low level, the RPC level, pretty much everything that is possible on Ethereum is exposed through these. And right now, the most popular abstraction is called Ethers.js. So if you go to npm and Ethers.js, you'll find, or is it just called Ethers these days?
It's just Ethers on
It's just Ethers. Yeah, this is a popular one. Truffle is another more full-featured framework that also manages how to interact with smart contracts. So Ethers makes it easy to do a variety of things. So usually what will happen is you'll have this ABI that describes your, that was useless zoom in. You have an ABI, a binary interface, application binary interface that describes the interface of a contract. And this file you'll get from your compiler, and you'll usually feed the ABI into whatever abstraction you're using, which will then generate a convenient API surface in whatever language you're using. So if you're in JavaScript, it'll read through the ABI and it'll say, oh, okay, there's a transfer method on the contract. I'm going to give you a JavaScript transfer method. So usually what will happen is after you write your contracts, you're going to come out with an ABI. You're going to feed that to some convenience library that now gives you a very friendly way of interacting with that contract from the browser. And so, for example, if you fed it the MetaMask provider, now when you call functions on your new JavaScript object, if that function is going to invoke a transaction on the blockchain, that will then prompt MetaMask to prompt the user for whether or not they want to do the thing. Yeah, there's Ethers is a good one. Truffle is another good one that is on the slides.
So Dan, is the overall model, you've got a web server which returns JavaScript, and the JavaScript via this API calls MetaMask in the web browser, assuming the web browser is Google Chrome.
Yeah, you'll have some server that's serving up some web front end. Now we are working on allowing you to host those interfaces over more decentralized protocols. So we do support loading over IPFS today, although it's doing some kind of janky stuff where it replaces the URL. Fortunately, the web browsers just shipped an API that will allow web extensions to keep the URL. So we're going to be able to have IPFS : // you'll be able to load pages off of that. So you'll be able to have static references to canonical interfaces for the contracts that you're interacting with.
What happens if someone's using, say, Safari or Firefox or, I don't know, Internet Explorer or whatever the current browser is on Windows? What happens then?
Edge. Yeah, so most of those all support the standard web extension protocol. It was pioneered by Chrome, but Firefox supports it, Edge supports it, Opera supports it. And so we're available on a variety of browsers. We're actually not quite in Edge yet, but we will be soon. Safari actually, there was a new release at WWDC. Safari had their own extension protocol for a long time. They're finally going to adopt a more standard one. So we should be coming to Safari probably sometime in the next year.
That's really cool. So I've got a ton of questions, and I don't want to just like steal the floor just in case other people do. But so we're on mobile. If I've got a mobile app, is there a way of doing mobile to mobile communication so I can use my mobile app, can use MetaMask's mobile app to do some payment or whatever?
Currently, it all relies on an internet connection, although we are very excited about allowing more, like, almost sounds like you're talking about mesh networking type stuff. We had a very fun kind of mind meld with some of the people at FireChat this last year, and they're thinking about very similar things, and they are hoping to eventually have things like a web framework or a SDK, so we could potentially, I look forward to the day we can import something and enable mesh networking. But for the time being, since MetaMask mostly supports blockchains that rely on global consensus, if you don't have an internet connection, you're not really going to get the benefits of that. Mesh networking is really going to become most powerful when you're using smaller consensus systems. So either a state channel, so we could open a state channel before we go offline, and now we have rapid payments offline. Or if we just spin up a smaller ledger that's maybe kept locally. I think, yeah.
Yeah, what I was actually thinking about is, say I've got a, I don't know, an auction app. You know, so I write my own very own Android app, which is an auction app, but I want to allow people to pay in crypto. And how I want to do it is I want to essentially, I say, you know, click pay, and then it suddenly goes to MetaMask and have the integration between the two Android apps. Does that make sense?
Dan, you're muted.
Oh, sorry about that. I may have visually said what I was saying verbally, though. If you go to our docs page, docs MetaMask.io, under the mobile section, you'll see we have a deep linking section, which I believe is the exact topic you're broaching. We have even a little widget to make it easy to create. Right now, we only support 3 types of deep links. So the ability to open a specific page in our browser, the ability to request a payment, like your example was, and also the ability to initiate a payment channel request, which uses a kind of experimental feature that's on our mobile device. So we hope to eventually extend this to support everything that our RPC supports. And so yeah, the future of Web3 does not need to be browser exclusive. I think it makes a lot of sense to make premium experiences native.
That's really good. Cool.
Oh yeah, Dan, just thinking about the mesh networking thing, I guess something that could perhaps happen sooner, if you had your own, you know, local Wi-Fi network, as long as you were running, you know, the MetaMask server in this network, you know, running it yourself, then I guess, yeah, like I guess you could have all the pieces to run your own economy locally, couldn't you?
Yeah. And actually, I was working on just like, this is not like production ready, but in my own time, I like have an annual. I was actually helping coordinate a summer camp, and so we would be offline for a week. And I was building a little Raspberry Pi that you could bring anywhere. And actually, I think it's very reasonable to say, look, if you've got a Raspberry Pi and a router, yeah, you've got enough for your own internet. And MetaMask supports pointing at your own RPC connection for the blockchain. And we allow custom networks also. So not just the Ethereum network, but any Ethereum compatible network. So for example, our friends down at Truffle, they make developer tools around Ethereum. They also have a very nice test blockchain called Ganache. You know, it's a single validator blockchain. So if you're going to run an economy on a single Raspberry Pi, you have no other validators. Ganache has everything you need. It's enough to run a blockchain state, save it to disk, resume it later, keep everyone's balance correct, manage gas fees, all that stuff. So as long as everyone's on the Wi-Fi, yeah, you could totally have like a camp out microeconomy using MetaMask today.
Sounds great. I'll have to check it out.
Yeah. Let us know how it works. I think mobile may still be enforcing HTTPS, which would be the hardest part of that arrangement. On desktop, we let you connect to any RPC. We may need to laxen that security measure for this use case.
So you talked about adding support for layer 2 solutions and other, you know, layer 1 solutions. How do you choose which one is next, you know, because obviously you've only got so much development bandwidth, and, you know, how do you choose which should be supported?
Right, and so that is the problem that our plugin system is attempting to solve. Because the answer to your question is, we don't know how, you know, like it's an extremely hard question to answer. Like which, you know, first of all, before any of them have really launched, like which layer 2 or which layer 1 are we going to build a bespoke integration for next? And then second of all, it's also a sort of kingmaker-like position that we don't want to be in. And we'd much rather have a situation where, like we provide a platform with an interface that users are extremely comfortable with, and then the developers of these various layer 1s and layer 2s are able to build an integration with MetaMask themselves that can be installed at runtime when users go to their web interfaces of those applications.
So say if you were, oh, sorry, go ahead.
Oh, sorry. Hi, this is Carlos. I have a quick question, and I don't know if you have the answer to this, or it's more about to hear your thoughts considering the space you're in. So you constantly hear, at least, about the issues that private keys remain the single point of failure. So I was wondering if you have any ideas, or have you addressed in any way what are your plans, or what is the space doing about recoveries or alternatives to figure it out a way, because the user is the user at the end of the day. And second, have you heard of any of, like, there's this multi-party computational technology that is coming where they're splitting the keys so that there are two, it's not like Shamir, like the secrets that you have it, but they happen completely separately to avoid a single point of failure. So I was wondering if you have any idea if that technology is ever maybe gonna make wallets.
Rochambeau? Okay. Yeah, I mean, really, it's, I hate to feel like a broken record, but there are multiple categories in the wallet, basically, we felt like are so ripe for innovation that we felt like they are worthy of a plugin system. And it really cuts to the heart of it. So in our developer beta so far, which we've taken to a number of hackathons, we've already successfully integrated contract accounts within MetaMask. And now there's a kind of long road to finalizing. Well, it's not too long. Like I think that we had to iterate, and we wanted to really explore all of the challenges there were. I think we're really kind of on the home stretch. But yeah, a plugin for an account it's a script that describes your account. It provides an interface similar to our current key managed accounts, but it can have its own security properties. So on Ethereum, today, any contract could be an account, and that's great. There are some very cool contract accounts. I'm a big fan of Gnosis Safe and any.sender, and they offer benefits in a variety of ways. And Gnosis Safe even supports modules. You can actually extend the wallet itself. You can add new signers for a given function. There's so many things that are possible that we don't even want to just integrate a single one. Also, if you integrate a single contract account, you could find yourself in a situation like the Parity multisig. They built a whole wallet around a single contract account. A vulnerability is found in it. They've destroyed their entire user base and their entire company. We don't want to put all of our eggs in one basket. We want users to be able to take the risks that they want to take. Yeah, that means that we're doing keys to start. But it also means that you always have the choice to use keys. And keys are very powerful because if you have this number secret, then you have total control. That is a very good starting place. And then from there, letting people add any contract account seems like a really big deal. When you start getting into other cryptography, like kind of shared secret, not Shamir's, but I was thinking, well, what's that one where it's proxy re-encryption? I don't know if that's maybe the kind of thing you're talking about. But obviously Ethereum doesn't support that for base layer accounts today. But just last week, Vitalik submitted a new EIP for account abstraction on ETH1. So if he has his way, we will ship account abstraction on Ethereum 1, next year. And that could mean that you pick new encryption schemes for your accounts. Now, how do wallets allow users to pick any new encryption scheme? Well, they need to be able to integrate new encryption schemes as they're devised. And so again, it puts us into that loop. Either we are picking and choosing correctly in a field that we are not the experts in, or we're creating an ecosystem that allows users to opt into things they are informed about and recommend those things to their peers. So I think it's going to be a very exciting space. Once we crack this nut and make it so you can add anything, then I just can't wait to see what the developers do. Like, I really feel like we're about to just unleash something pretty powerful in the hands of developers.
Thank you. If no one has a question, then I have a follow-up to your answer,
Yeah, go for
which
it.
is definitely the alternative to having these issues, or like a lot of exchanges, how they do is like they have the smart contracts to manage, you know, people's funds and do stuff and all of that. However, that is becoming or turning out to be expensive, because in addition to, you know, the transaction, you have to pay the computational gas and all those kinds of things. So using smart contracts as wallets, as far as I know, and I'm not expert, it's a little bit more expensive than if you have the user itself, right? So I mean, my previous question was not at all like trying to say like, hey, why are you using private keys? I perfectly understand why you use, and it was not a kind of a criticism in any way. It was just a thought of how we as the community could figure out a way to tackle the issue, because a lot of the, I don't know if you like front end running, and a lot of different things that are happening on the space are because users are like having issues with their private keys. So I was just wondering if you had any ideas as a wallet.
Yeah. So stepping away from like how the wallet integrates it, and just like how does the protocol do it. I think account abstraction is a really important measure. For those who aren't familiar with the account abstraction model, basically what you say is, okay, actually every time you submit a transaction to a miner, there is an implicit gas cost that you're not paying. It's the computational cost of validating your signature. And if we say that the cost of validating your signature is basically like 21,000 gas, and that's the base fee of every transaction, then actually miners are giving away free gas all the time, right? Every time you send a signed transaction to miners, they are validating some computation. So what if we said we can make that part open-ended? We don't have to hard code it to the ECDSA algorithm. We can say actually any transaction gets a free 21,000 gas to be validated with. And then the first segment of bytes on such a transaction could specify the contract to validate itself with. So miners could receive a new transaction. They go pull up the contract for validating. It's got to be cheap, you know, but it can be good enough to validate any elliptic curve, add in BLS, possibly some multisig. And so that will open up a domain of creativity to reduce gas cost. I don't think that contract accounts are always more expensive. Specifically, contract accounts save money when they batch transactions. And you can't batch transactions from externally owned accounts. But you can have a whole bunch of contract accounts whose transactions are submitted as part of a larger batch. And when that's done, you are able to eliminate the upfront cost, the base fee that every transaction fee pays. And so through batching and through the creativity made possible by account abstraction, I think that there's still a lot of room to explore how to increase the performance of new kinds of accounts.
Thank you.
And I'll add to that too. Like one of the reasons that because I, like Dan, I'm equally excited about the prospect of adding different kinds of accounts via our plugin system. But one of the reasons that I go to different layer 1 protocols, and in the case of Ethereum, layer 2 protocols first, is because it's increasingly clear to me, and I think the ecosystem as a whole, that we need these layer 2s in order to make using Ethereum more affordable. And I think currently, even with all the excitement going on in DeFi, which is, I think, overall like very positive for the ecosystem, it does have with these high gas costs that we have, it has turned it into something of a game for wealthy people with a lot of time on their hands, right? Like, we're not going to see people making less than a few dollars a day going onto Ethereum and doing anything that is like important to their material well-being when transaction costs are what they are at the moment.
Yeah, makes sense.
I'd like to go back to something you said, Dan. So you said people go and batch transactions, and so like put a whole heap of transactions together. Do we actually, have you actually seen people do that? And you know, what context is that?
Yeah, so right now there's been an ongoing experiment in that field by the any.sender team. It's a team that implemented the escalator algorithm, which I know you guys had a talk about recently. They implement the escalator algorithm in such a way that they forked MetaMask so that it can support a contract account that supports batching. And then they relay the transactions with an escalating gas price. And so the result of that is you both get the gas cost savings of being batched, and you're getting the gas cost savings of the escalator algorithm, which is going to progressively increase the bid price for your transactions. And so they were finding that they were, just through the escalator algorithm, getting like 20% lower transaction fees. And then combine that with the batching, that's another 21,000 gas off of each transaction. And so I think it's already been pretty well demonstrated that there is a lot of savings to be had. But you know, it has to be integrated at the wallet level. Or, sorry, there is one other way. You can also support meta transactions through a universal relay, which there is an initiative on right now, partly spearheaded between any.sender and the gas station network. They're working on, I'll have to dig up the name of the EIP, but there's an EIP for a universal relay. And this would allow contracts to basically, when you publish a contract, you would specify the universal relay as an accepted validator of transactions. And so then any user could sign a transaction that, you know, it's not an Ethereum transaction, it's a message that is valid to be submitted through this relay in a batch, potentially by someone else, potentially paid for in another token, and so forth. Yeah, I will get that for you.
Yeah, thanks. And so when you're sending these batches of transactions, do they all have to be signed transactions by the same EOA, or could they be, you know, like, okay.
Yeah, so the way the relay would work is basically each message. So to understand why it even is a thing, there's this coupling in Ethereum transactions today, where it's the message.sender problem is what we sometimes call it. The person who signed the transaction becomes this global message.sender thing. And it's what every contract uses to enforce its authorization logic. And the problem with that is it means that there's no way to now decouple for those contracts. You can't decouple authorization from who paid for the gas for the transaction. So the whole correction is we have to decouple those. And you can just do it with good programming practices. And that's what this universal relay is intended to do. The idea is instead of using message.sender to authenticate a message, we're going to have the main signature, the message.sender, that's just the gas payer. And now there will be these sub messages that are signed that represent the authority to perform a given function. And so you can have any number of those messages signed together, batched, and submitted to the relay by anyone. Message.sender doesn't matter. And now each of those contracts would register that universal relay because you would have verified its source code, that it will only forward to your function if it has verified that you know, one of those messages signers, right, well, the message, right, it's going to append the signer's address in the message that it sends forward. And so trusting the universal relay is trusting the authority of your contract to the relay. And so it's very important that we basically standardize on it and audit the heck out of it. So then once we have one that we can all really trust, we can just publicize that address very, very well, and then just be kind of done with meta transactions.
All right, so while Dan's digging up a link for that, are there any final questions? So doesn't appear to be.
That is a EIP 2585 is the, yeah.
Yeah.
So I'll drop that in there.
Yeah, thank you. All right. Well, look, Erik and Dan, thank you very much for presenting today and answering all these questions. It's been really interesting. I know I've learnt stuff. I'm sure many other people have too. So everyone, let's give you a virtual round of applause. Yeah.
Thanks, guys.
Yeah, thank you.
Cool.
All right.
Yeah. Thanks so much. Yeah. Thanks for having us at your nice meetup.
Yeah, not a problem. It's been great having you. So this recording will be on YouTube later today. And yep, so see you all in 2 weeks' time for introducing quorum or consensus quorum. Right, see you later.
Cool.
Thanks, Dan. Thanks.